Okay, but today we are starting with a new topic that is for the mathematics tree further coordinate systems. For the coordinate systems, right? Okay. So from this equation, first of all, we should know about the ellipse. The first subtopic we are discussing about the matters of ellipse. Yeah. Now, when you're discussing about a ellipse, you can see ellipse is a shape somewhere like this. So we can just draw the basic concept of a ellipse. It's just a shape like this. It goes like this way around, and which is passing through these coordinates over here and here. This value is A. This is minus A. It's a symmetrical shape. This is minus B and this is plus B. So if you just draw it in a coordinate axis somewhere like this, it's a basic shape of a ellipse. Right? Then if you get the Cartesian equation of a ellipse, Cartesian equation of ellipse, you can say x squared over a squared plus y squared over b squared is equals to 1. That is the Cartesian equation of a ellipse. Right. Okay. Then we should know how to form a parametric equation. This is a Cartesian equation. We know what we mean by the Cartesian equation. What we mean with parametric equation. Parametric equation become this way. X equals to a cos t and y equals to b sin t. So we can prove this concept over here, just like this. So how to form this parametric equation to Cartesian equation is, we know that x equals to a cos t. Therefore, you can write from this equation, you can say cos t is equals to x over a, y equals to b sin t. That means you can say sin t equals to y over b. Then we know that cos squared t plus sine square t is equals to 1. So from here you can say x over a whole thing squared plus y over b whole thing squared. This is equals to 1. So with that you can write the equation x squared over a squared plus y squared over b squared is equals to 1. So this is the Cartesian equation and the parametric equation of a ellipse, right? So you should know the Cartesian parametric equation, Cartesian equation. We should know, get it. These are the equations. So you should be able to get these equations, and we should know how to do this proof. So from the parametric equation, you should know how to do this. This is a proof. Yeah, right. Okay. Now let's see from a question how to understand the concepts of this Cartesian and parametric equation. That's a factor to understand over here. For example, if you happen to see an equation of this one, 4x squared plus 9y squared equals to 36, right? So we need to draw the ellipse based on this Cartesian equation. So I will divide all of these expressions by 36. Then see what you get this from this expression for the over 36 plus 9y squared over 36 equals to 36 over 36. What is the purpose of doing this? The purpose of doing this is the parametric equation, sorry, Cartesian equation of ellipse is this way equals to 1. So we have to make this number as 1. So this is turned up to x squared over 9 plus y squared over 4 is equals to 1. So this is, then you can say this is x squared over 3 plus y squared over 2, 3 squared and 2 squared is equals to 1. Now you can understand that according to this one, if you just draw this graph, it's passing through 3n minus 3 today. Minus 3 and this is passing through 2n minus 2. So it's a graph somewhere like this. This is x and this is y. That's a graph where we should know how to do it. Then if you need to draw the parametric equation for this particular parametric equations, right? We know that if this is a and b, the parametric equation is a cos t and b sin t. So parametric equations become x equals to 3 cos t, it's related to the x value, and y equals to 2 sin t. These are the parametric equation for this respective uh, equation of an ellipse. So this is a concept. I'll just make it a little bit of minimize, then you can see the complete node. So if there's an ellipse which is passing through a and b over here, the Cartesian equation become x squared over a plus y squared over b squared equals to 1. Parametric equation is x over a cos theta and y equals to b sin theta. So this is the proof of forming parametric to Cartesian equation. This is the equation of that project, right? That's how it comes, right? Okay. Then let's come up with another example. So if you happen to see an equation just like this, but they might give you, sometimes they used to give us in parametric formats, but they have given the equations just like this. X equals to 3 cos t, cos theta, and y equals to 5 sin theta. So this is pretty simple. Then we need to find the sketch of this graph with it. So x is related with 3 and y is related with 5. So this is 3 and this is minus 3 and this is 5 and this is minus 5. So you can just draw it ellipse just like this. That is an ellipse. Then if you want to get the Cartesian equation, so you can say this is x squared over 3 squared plus y squared over 5 squared is equals to 1. That is the Cartesian equation for this. That's a way of getting this answer. So you can get any kind of Cartesian or parametric equation, and you can convert into any and you can do the sketching part even. It does not make a difference with that, right? Okay. So from this equation, you should know how to do this. What do you call that? If you know the parametric equation, you should know how to convert to the Cartesian equation. If you know the Cartesian equation, how to convert the parametric equation, and as well as we should know how to find the equation of a ellipse. That's the main thing where we should know today. Right. Right. So sketch the following ellipse in the following clearly the curve with cross-sectional coordinates. You can find these ones very easily. So divide everything by 16 and get it. And this is divide everything by 36 and get it. And this is divide everything by 25 and get it for that. So if I just work out this kind of questions, so just like this, x squared over, I just do this part of x squared plus 9y squared. Plus 9y squared equals to 25. So if you want to get this answer, you have to divide everything by 25. 25 and 25. So this is turned up to x squared over, this is 5 squared. And this one you can say y squared over 5 over 3 squared. How do you write this one? Because I can bring this 9 down and write it as a fraction, because the fact is x squared over a squared plus y squared over b squared is equals to 1. That's the format of it. So if you sketch this graph, you can say it's just a graph like this, traveling from 5 and minus 5. This is 5 over 3 and minus 5 over 3. So just a ellipse somewhere like this. That's what you need to get it from this. That's a it's not a ellipse actually. This my drawing is kind of bad, but anyway, that's a way of getting this. So you can come up with that kind of situations, right? Okay. Then Pute, let's go to this question. This is kind of a different, not a different one actually. Only thing is that it form up. The diagram shows a circle with the equation x squared plus y squared equals to a squared and x squared plus y squared equals to b squared. Line OS makes an angle theta to the positive x-axis and intersect the circle at point P and Q. Right. Okay. Therefore, in a same order, the things already mentioned. The point R has a same coordinate as P, same y coordinate as P, and the same x coordinate as Q. Right. Okay. Find the coordinates of R in terms of A, B, and theta. Right. Let's see how do you need to find this value. So over here, there are two circles with the same center. Just excuse if my drawings are a little bit of bad. Right, and this is it. This is the center. Anyway, here this coordinate is A and here the coordinate is B. Right, they have drawn a line somewhere over here. And this is like that. Then Pute, you know that this length, if I just work out the length over here is how much, Pute? That is A. Then if you measure the length from here to here, that is B, the same radius, Pute. And this angle is theta, right? Okay. Then what they specifically mention in this question is there is a point which is having the same y coordinate as P and same x coordinate as Q. This is P and this is Q. Right, so it's just like this. So we need to find the coordinate over here. That's the first part way to understand. Now you can see, Pute, this, if I just get this one over here, it forms an angle somewhere like this theta, and this radius is A, Pute. So this value you can write A sine theta. Therefore, here the coordinate is A sine theta. Here, therefore, it gets the same y coordinate. So the y coordinate becomes here is A sine theta. Sorry, should be A sine theta. And the y-x coordinate put it. So over here to here, we know that if you get this triangle, it's just like this. It's B. From here to here, it's B. This Q, and this is P. I'm just referring to. And this angle is theta. So this is B cos theta. So therefore, x coordinate becomes, sorry, I drew it in a wrong way. The y coordinate is A sin theta. This is A sin theta is a y coordinate, and x coordinate become B cos theta. I think you can understand what I drew over here. That's all. This is a value over here. So this is same y coordinate, that is B cos theta, and this much. Then what they refer is hence it describe the locus of R in terms of this much in the Cartesian equation. This is pretty simple. So here the coordinate, the variation of coordinate is B sin theta and this bit. So you can say this part. X coordinate is equal to how much? B cos theta. And y coordinate is equal to how much? A sin theta. Therefore, out of this one, you can say x over b equals to cos theta. And this is y over a equals to sin theta. This is a parametric equation. If you get it, the same proof over here. Cos theta equals to 1. Therefore, you can say x over b whole thing squared plus y over a whole thing squared 1. So this is, what is this equation for the x squared over b squared plus y squared over a squared equals to 1. So what is this equation for the? It's a some kind of a ellipse. Over here, it's intersect a axis at b and minus b, and x axis at a and minus a. That's a way of getting this answer for this question. Yes. Then those are the main things we should know about ellipse. Then the next theory we need to understand is about an hyperbola. Hyperbola. So when you're concerned about a hyperbola, hyperbola is a shape somewhere like this. So it travels to 0, just this way. And hyperbola is a shape somewhere like this. But the blue color one is the hyperbola. Here the coordinate is A, and here the coordinate is minus A. Okay, the next part is we need to understand about these two lines. This axis has some kind of relationship, that is y equals to b over ax. Later on we'll come up with what is this b over x and that stuff. This is y equals to minus b over ax, right? Then we should know what is the Cartesian equation of this hyperbola. Cartesian equation. You can say the Cartesian equation is x squared over a squared, the same thing. In our ellipse, what we get is x squared plus y, x squared over a squared plus y squared over b squared, but here it's turned up to minus. There is a difference between that. Over b squared is equals to 1, right? So when you're working out with this, how do you form the parametric equation for this? Parametric equation. There are two types of parametric equation. First type of parametric equation is in form of trigonometric equation. X equals to a sec theta and y equals to b tan theta. Then we know that for the sec squared minus tan squared equals to 1. From here you can get it. The second one is you can use the alternative, like the what do you call that, we can use the hyperbolic functions. X equals to a cos theta and y equals to b sin theta. So basically this is the most common equation, and for most of the situations, but some situations we use this equation as well. So these are the A and B, and you can get the rough idea on that. How do you supposed to work out with this, right? Okay. Now let's see what kind of questions they can ask you, right? They might give you a parametric equation like this. 9x squared minus 4y squared is equals to 36, right? Then what you can get here is that they ask you to sketch this graph. To sketch this graph, initially I want to make this coefficient as 1, because you can see here the equation is equals to 1, right? Okay, therefore I will divide everything by 36. Then what do you get with it? 9x squared over 36 minus 4y squared over 36 is equals to 36 over 36. Then this is turned up to x squared over 4 plus y squared over 9 is equals to 1. So this is x squared over 2 squared plus y squared over 3 squared equals to 1, right? Then what you can get here is, it's a graph somewhere like this, and we should know this line somewhere like this way around. Then put it here, the number in front of before x is 2, therefore if you just draw it, it just comes like this way around. Put it this way, and we should know this coordinate. Put it here, the coordinate become how much? This coordinate become 2, and this coordinate become minus 2, and this line is, what is that? With it y equals to b over ax. B is this bit, 3 over 2x, and this is y equals to minus 3 over 2x, right? Then they can ask you is the parametric equations. The parametric equation, how to write it with it? Parametric equation. So you can say the most prominent parametric equation is this. So therefore you can write x equals to a is 2 cos theta and y equals to 3 sin theta. That's a way of forming the parametric equation for that, right? Okay. Right. Then, yeah, that's the first type of question they can ask you. Second one is sometimes they might give the parametric equation. x equals to 4 sec t and y equals to tan t. We need to find the Cartesian equation and sketch this graph over here. So what you can get here is that you can say sec t equals to x over 4, y over 1 is equals to tan t. Then we know that 1 plus sec square t is equals, sorry, 1 plus tan square t is equals to how much? Sec square t. That is, therefore you can say sec square t minus tan square t equals to 1. The sec square t you can get x squared over 4 squared minus y squared over 1 squared is equals to 1. So if you sketch this graph, you can understand that here it's a graph somewhere over here. I mean, it's a shape like this way around, and it comes a shape over here. This is 4 and this is 4 and this is y equals to b over a. B is 1 over a. Oh yeah. 1 over 4x, and this is y equals to minus 1 over 4x. That's a way of getting the parametric equation and the sketching part like that. That's a way of getting it. Just make it a little bit small, then you can see the entire stuff at once. Just make it a little bit smaller, then you can refer the entire things at once. Right, okay. Right, when you come up with these questions, you can see we need to find the hyperbolic parametric equation, divide everything by 16, x squared minus 4y squared equals to 16. So if we just out. So if you need to find this kind of a question, we'll get it like 9 x squared plus we will get 16 y squared equals to 25. So what you need to do is, if you need to get this, so you have to divide everything by 25 to get the equation of parametric format. So you can say 9x squared over 25 plus 16 y squared over 25 is equals to 1. So it's turned up to, you can say x squared over, this one you can say 5 over 3 whole thing squared. This one you can say y squared into 5 over 4 whole thing squared is equals to 1. So with that, you can say it's traveling through, it's a graph somewhere over here, just like this, and this is y equals to b over a. The y equals to b over a. B is 5 over 4. Over means divide by 5 over 3x. That is it. That is y equals to 3 over 4x. And this is y equals to minus 3 over 4x. Right. Then you can draw the graph somewhere like this way around, and this value is a. A is this bit, 5 over 3. And this is minus 5 over 3. So that's a way of getting the answer for this kind of a question. So it is not that hard. And yeah, so here they have given in the parametric format. So with that, even you can get the solutions of this, what do you call that? Parametric, of the hyperbola. So now those are the things to be learned